Let's understand the proof of area of an ellipse. But for that, please do like, share, subscribe, and please support this video. Now let's start. So first of all, let's draw a rough diagram of an ellipse. So it looks somewhat like this. This is x-axis and this is y-axis, right? So its coordinate is negative a comma 0 and this is a comma 0 and this is 0 comma b and this is negative b, right? So we need to find its area, and I don't know why many people are petrified of finding its area. I don't know why they should, because I think it's very easy proof. So let's see how we can prove it, and let's remove that fear. Okay, so we all know that the equation of an ellipse is given by x square by a square plus y square by b square is equal to 1, right? So this point is 0 comma 0. Of course, its origin. Okay, so how we can find the area of ellipse? Well, we all know that the area is given as integral a to b fx dx, right? Of any curve, area under any curve, right? So similar is the case with this ellipse, right? So this is we have the coordinates negative a to positive a in x-axis and negative b to positive b in y-axis, right? Okay. So we know the equation of this curve, right? So let's solve for y in this, right? Since y is equal to fx, we assume it like that. So x square by a square plus y square by b square is equal to 1, right? Okay. So from here we can say y square by b square is equal to 1 minus x square by a square, right? Okay. So what we can say is that y is equal to b square 1 y square 1 minus x square by a square, right? Now we can take square root both sides, so we will have y is equal to b 1 minus x square by a square. Now note, I haven't taken plus minus over here because if I will take plus minus then it will be a problem. We all know that this figure is symmetric about x-axis, and of course if you are calculating it along y-axis, then of course it is symmetric about y-axis too, right? Because if you are calculating area like x dy, then you can assume that this ellipse is symmetric about y-axis. Okay, so that is why I am assuming y is equal to b into root 1 minus x square by a square. That is only the upper portion of this ellipse. Okay, so what we will do is that we will integrate it from negative a to positive a y dx, right? Okay, but we require something more in this. We require 2 also. Why? Because again this is only for the upper region, so we have to find the complete area, so we have to multiply by 2. Okay, so now simply let's evaluate this integral. What we will be getting? We will be getting integral negative a to a b times the quantity 1 minus x square by a square. For now I am neglecting this 2. At the end I will multiply by it. Okay, dx. Okay, so we can absolutely take b outside, so we'll have b times the point negative a to a root 1 minus x square by a square dx. Okay, now of course it's an even function, so what I can do is that though it's not required, but still I can write it like 2b times the quantity integral 0 to a root 1 minus x square by a square. So let's do that. So it is 2b integral 0 to a root 1 minus x square by a square dx, correct? Okay, now let's assume x is equal to a sine theta, correct? Okay, so we'll have dx is equal to a cos theta d theta, correct? Okay, so we have this expression integral 0, and when x is equal to a, sine theta is equal to pi by 2. I mean sine theta is equal to 1, so theta is equal to pi by 2. Okay, pi by 2 times the quantity 1 minus sine square theta a cos theta d theta, correct? Okay, now let's evaluate this. So clearly we can take ab as common, I mean a as common, so you'll be getting 2ab times the integral 0 to pi by 2. This is a mod of cos when you take its square root, it will be the square root of cos square theta, so it will be mod of cos theta. But we all know that in the limit 0 to pi by 2, cos theta is always positive, so mod of cos theta will be cos theta only, right? Mod of cos theta is equal to cos theta for 0 to pi by 2. I should write it differently. For 0 to pi by 2, correct? Okay, so I have this expression cos square theta d theta, correct? Okay, now how we can evaluate this? Well, it is very simple. Let me erase this. So we all know that there's some relation between cos 2 theta and cos square theta. What is that? We all know that cos 2 theta is equal to 2 cos square theta minus 1. So we have cos square theta is equal to cos 2 theta plus 1, or I should write 1 plus cos 2 theta divided by 2, right? Okay. So we have to evaluate this expression, and since we have to multiply by 2 also, so I should write it as 4ab, correct? Okay. So 4ab integral 0 to pi by 2 cos square theta d theta, it can be written as, let me erase this. So on solving, what will be getting? You all can also solve it. So you will be getting it as 4ab times the quantity. This will be 0 to pi by 2 of the quantity 1 by 2 d theta plus 0 to pi by 2 of the quantity cos 2 theta divided by quantity 2 d theta, right? Now, how we evaluate this integral? Well, it's very simple. It is simply 4ab times the quantity. This will be 1 by 2, 0 to pi by 2, right? And what's the integral of cos theta? Well, it's equal to sine theta, right? So we'll be getting it as cos 1 by 2 times sine 2 theta divided by 2, 0 to pi by 2, right? If you have any doubt why the integral of cos theta is equal to sine theta, let me prove it also. Well, it's not required, it's very simple still. Cos theta is equal to what? It is equal to 1 minus x square by 2 factorial plus x cube by plus x to the power 4 by 4 factorial and so on till infinity. So when you take its cos x, so when you multiply by dx both sides, you will having dx, dx, dx and so on. And when you integrate it, what you get? This is integral cos x dx, it is equal to x minus x cube by 3 factorial plus x to the power 5 by 5 factorial and so on till infinity. And this is equal to sine theta. So it is sine x plus some arbitrary constant, right? So now when you substitute the limit, at 0 sine theta is equal to 0, and at pi by 2 sine 2 theta will be equal to sine of pi, which is equal to 0. So this is equal to 0, right? So we have 4ab times the quantity pi by 4, and it is equal to pi times ab, and that is the area of an ellipse, right? So it doesn't matter if the ellipse is like this or like this, it doesn't matter, right? It has the same area. Okay, so this is how you calculate the area of an ellipse, and there's no need to be frightened of it. Okay, it is very simple. Okay, so if you enjoyed this video, then please do like, subscribe and please support this video.